Played that in a while. I think they're called petite.
Hello, this is Pratik. What? We're playing Mathsketball? Oh, snap! I'm there!
My boy, Michael, the mathematician, Gregory!
Yeah, he's special!
Mathematician strikes again!
Dixit!
Dixit! Dixit! Dixit! Dixit! Dixit! Dixit!
This works for Sokotoa!
And Dixit!
Yeah! Whoa! He's awesome! Look at that skill!
Show me the way, man. Yo, geometry, it is so cool. Miss she taught us in school that if you know all the rules, you'll no longer be a fool. Check it out.
Yeah, that's what I'm talking about. Pythagoras, he was a Greek, but all y'all said he was a geek. Sokotoa, he was my man, he even came from an Indian tribe clan. Yeah.
Yo, right angle, 90 degrees. All this knowledge gonna make you freeze. All the pretty women in love with these.
Why that, boy?
'Cause I do geometry.
Yeah! Oh, that's right.
Word to your mother.
Basketball, yeah! I'm Pratik, and we're here to show you how you can apply your geometry skills to real-life basketball. It's a little something we like to call
Basketball. Well, we're gonna start you off with a little easy problem here. God's greatest invention. Well, the distance from the basket to the free throw line is obviously 12 feet. But I want to know the distance from the basket to the three-point line. See,
This point is the basketball hoop, point B. Here's the foul line, and here's the three-point line. Now, the easiest way to go about this problem would be to make two triangles and then solve a proportion. So, we're going to make two triangles here, and before we do anything else, we have to name this. Now, what's a good five-letter word?
beach.
Yeah, man, that's good. B-E-A-C-H. So now we have to prove that triangle BEC is similar to triangle BAH. Now, we're going to set up our little chart here with the statements and reasons. Now, we always know that when we start a proof, you always start with the given. Now, I know that we play on a very mathematical basketball court, therefore meaning that the foul line is parallel to the three-point line. So, our first step is going to be EC is parallel to AH, and that's given. Now next, since I know that these two lines are parallel, I can see that BH is a transversal, meaning that this angle, angle H, and this angle, angle C, are congruent by the corresponding angles theorem. Therefore, our second step is angle C is congruent to angle H by corresponding angles. Alright, now, our third step here is that we know that both of these triangles share angle B. So therefore, we can say that angle B is congruent to itself, angle B, by the reflexive property. our final step is that now we're going to prove that these two triangles are similar. And we can do so by the angle-angle similarity theorem. Alright, that was awesome. So once again, I'm going to draw our basketball court. The basketball court once again. Now, while I was talking to you, Mike informed me of the side lengths. Now, from the basketball hoop to the foul line is 12 feet. And from the basketball hoop to the other side of the foul line is 15 feet. And from the foul line to the three-point line is 5 feet. Now we want to find out what x is. So we're going to set up a proportion. 12 over x equals 15 over 5. Now, as Ms. Sheets has always told us, we have to simplify this. So that works out into 3 over 1. Pretty simple. So now we could say that by cross multiplying, 3x equals 12. So you divide each side by 3, and you get an answer of x equals 4. So now we know that this is 4, and so the whole distance from the basketball hoop to the three-point line is 16 feet.
Jesse. And then we've also got Pratik and Waldo.
Waldo, honey, pull up your pants. Yes, Mom.
Now, we need to know if Jesse, from standing right there, will be able to make a shot at that basket.
Okay, guys, I'm gonna go calculate this on my computer. Graph off the satellite I've been tracking over the west. It's been orbiting there for several days. Okay, so I downloaded it via USB port. Here at the origin, there's the hoop. And there at 0,4 is Pratik. And then there's me at 5,4. Oh my god! My computer crashed! Oh no!
Don't worry.
Computer!
Don't worry, Jesse.
No.
We'll be able to save you.
Hoop at point 0, 0. Here we have me, Pratik, at point 4, 0. Here we have Jesse at point 5, 4. And here we have Waldo. His position is unknown. So, we connect these 4 dots. And guess what, guys? We get a rectangle! Now, I want to introduce you to a very helpful formula. It's called the distance formula. And it's the square root of x2 minus x1 plus y2 minus y1. And you square these. Now, let's put this formula to use here. We know that using this formula, the distance from the hoop to Pratik is 4, and the distance from Pratik to Jesse is 5. Now, since this is a rectangle, we don't even have to figure out these distances, since opposite sides are congruent. So therefore, the distance from the hoop to Waldo is 5 feet, and the distance from Waldo to Jesse is 4 feet. Now, I want to introduce you to a very important and special man. His name is Pythagoras. He came up with what is known today as the Pythagorean theorem. This theorem states that a squared plus b squared equals c squared, where a squared and b squared are the two shorter sides, and c squared is the long side, or the hypotenuse. Now, let's put this formula to use. We could split this rectangle into a diagonal. And since we know that in a rectangle, all the angles